When you look up on a clear, dark night and the sky above you is freckled with the soft silver dust of stars, it is easy to forget that you are not simply seeing lights, you are seeing lives. Each small point of brightness up there is a sun, a vast, hot, luminous sphere of gas, born of clouds, shaped by gravity, burning steadily for millions or billions of years. And each of those lives, quietly and gracefully, follows a long, patient arc, a story of birth and maturity and change, and in the end, a return. Tonight, I would like to tell you that story, the long, slow, beautiful life cycle of a star. We will begin at the very beginning, in a vast, cold cloud adrift in the dark, and we will follow one imagined star, together, from its first faint glimmer to its last soft settling into the deep. There is no need to hurry, stars take their time, and we will take ours. We begin in a nebula, a vast, quiet cloud of gas and dust, drifting in the empty spaces between the stars. Nebulae are some of the most beautiful places in our galaxy. Pale pinks, cool blues, soft greens, ribboned across thousands of light years of space. Most of what fills them is hydrogen, the simplest element in the universe, the same gentle gas that will one day make up most of every star ever born. Among the hydrogen, there is also some helium, a trace of carbon, a whisper of oxygen, a little silicon, a scatter of heavier atoms, all the remnants of earlier stars that have already lived and died. In this way, every nebula is a kind of quiet memorial, and every new star is a kind of quiet continuation. Nothing is truly lost. For millions of years, our imagined nebula simply drifts, cold, thin, barely disturbed, a single breath of movement per century, a single whisper of change per millennium. But then, somewhere within it, a small disturbance begins. Perhaps the shockwave of a distant exploding star has passed through, nudging the cloud together. Perhaps two nebulae have slowly, patiently collided. Perhaps gravity, in its own steady way, has simply found a place where the gas is a little denser and has begun to pull inward on itself. The denser region grows denser, it begins to collapse under its own gravity. Not quickly, not dramatically, but with the patient inevitability of water finding the lowest point in a bowl. As it gathers, it begins to warm. Atoms bump into one another more and more often, and motion, in the language of physics, is heat. The cloud begins to glow faintly, a soft, dim infrared. It is still not a star. It is what astronomers call a protostar, a star in the making, dreaming itself into being over a few 100,000 years. Already, in the heart of the nebula, a small, warm presence has begun to stir. For a protostar, time passes slowly. It gathers more and more gas from the cloud around it. Around its equator, a flat, spinning disk of dust and gas begins to form, and in that disk, in the tiniest, quietest way, the first grains of rock and ice begin to gather. Some of those grains will one day become planets, some will become moons, some will become comets that will one day trace long, slow arcs around the star. Even at its birth, the protostar is already building a family. At its center, the pressure and temperature climb, and climb, millions of degrees, tens of millions, and then, at last, something miraculous happens. The hydrogen atoms at the core become so hot, so tightly pressed together, that they begin to fuse into helium. Four hydrogen nuclei combine to form a single helium nucleus, and in that process, a tiny, exquisite amount of mass is converted into pure energy, according to the famous equation that Einstein gave us, E equals mc squared. That energy radiates outward, pushing against the inward pull of gravity. A balance is struck, the collapse halts, and the star is born. For a star like our own Sun, this balance can last for about 10 billion years. 10 billion patient, radiant years every second, the Sun converts about 600 million tons of hydrogen into helium. And every second, about 4 million tons of that mass become sunlight and warmth, and the soft, golden light that falls upon everything you love. It is a gentle, steady, extraordinarily faithful labor. Most stars spend the longest part of their lives in this calm, balanced phase, which astronomers call the main sequence. It is the star's long middle age, stable, luminous, generous. Around some stars, planets form and cool and develop water and atmospheres and, in the rarest and most wondrous cases, begin to host life. Our own solar system formed this way about 4.5 billion years ago. Earth orbits a perfectly ordinary middle-aged star, and yet, from that perfectly ordinary star, everything you have ever known has taken shape. But no star lives forever. Even the sun, so steady, so reliable, is slowly, gently burning through its hydrogen. And as the hydrogen at its core runs low, the balance that has held it steady for so long begins to shift. Imagine now that our star has been shining for 10 billion years. It has raised generations of planets. It has burnt slowly, patiently, through nearly all the hydrogen in its core. The fusion there has nearly stopped. Without the outward push of fusion energy, gravity begins to win, the core contracts and warms, and in response, the outer layers of the star expand and expand and expand and expand, cooling and reddening as they grow. The star has become a red giant, immense, luminous, pale orange. If our sun someday becomes a red giant, it will swell outward until its surface reaches close to the orbit of Earth. Mercury will be swallowed, Venus will be swallowed. Earth perhaps will be gently engulfed as well. It will not be a violent event, it will unfold over tens, perhaps hundreds of millions of years. The world will grow warmer, the oceans will eventually evaporate, the land will soften. The sky, at last, will fill with the red-orange glow of a star that once gave us everything. It is a profoundly slow farewell. But inside the red giant, something new is happening. The core, now contracted and very hot, begins to fuse helium into heavier elements, carbon, oxygen. The star has begun the next stage of its long, generous labor. It is making, within itself, the very atoms out of which future mountains, future oceans, future living bodies will be built. Every carbon atom in your own blood, every oxygen atom in every breath you have ever taken, was forged long ago, deep inside a red giant star. You are, in the most literal and beautiful sense, made of stardust. You always have been. For a star like our Sun, the red giant phase eventually slows, and the outer layers drift gently away. They form a soft, glowing shell of gas called a planetary nebula, a misleading name given long ago, when these objects were first thought to look like faint planets through early telescopes. Planetary nebulae are among the most beautiful structures in the universe, ringed, hourglass-shaped, blossomed into delicate clouds of color. The Ring Nebula, the Cat's Eye, the Helix Nebula. Each one is the exhaled breath of a dying star, dispersed slowly and gracefully into space. Within them float carbon, oxygen, nitrogen, and many of the elements that will, one day, become the next generation of stars, worlds, and living things. And at the center of that expanding nebula, the star leaves behind one last quiet gift. Its core, hot, dense, bare, a slowly cooling ember, a white dwarf. A white dwarf is about the size of Earth, but with the mass of a star. A single teaspoon of its material would weigh tons. It no longer fuses elements. It no longer shines with the light of nuclear fire. It simply glows, softly, with stored heat. A pale lantern, cooling through billions upon billions of years, so long that the universe itself is not yet old enough for any white dwarf to have fully cooled away. Somewhere in our galaxy, a white dwarf is currently glowing, faintly, with heat that was stored during the days of the ancient Egyptians, and it will keep glowing, quietly, long after any of us could possibly imagine. Now, not every star ends this way. Some stars are much larger than our Sun, 5 times, 10 times, 20 times as massive. For them, the story is faster and fiercer, and in some ways even more wondrous. Massive stars burn through their fuel quickly, sometimes in only a few million years. A time so short by stellar standards that it is almost a blink. They fuse hydrogen into helium, then helium into carbon, then carbon into neon, then neon into oxygen, then oxygen into silicon, and finally silicon into iron. At this point, deep within the star's heart, there is no more energy to be gained from fusion. Iron is the end of the mine. It cannot be fused without costing energy, and so, very suddenly, in less than a second, the core collapses. When that happens, the outer layers of the star rebound off the collapsing core in a titanic explosion called a supernova. A single supernova can briefly outshine an entire galaxy of hundreds of billions of stars. In that brief, extraordinary moment, the enormous pressures and temperatures of the blast forged nearly all of the heaviest elements in the universe. Gold, silver, platinum, uranium, every gold ring on every finger was forged in the dying breath of an ancient, massive star. And then the supernova expands, softly, into a remnant, a vast glowing cloud that will drift for tens of thousands of years, seeding the surrounding space with its gifts. New clouds will form, new nebulae will collapse, new stars will be born. Some of those stars will have planets. Some of those planets may even, one day, have oceans and forests. Perhaps on one of them, a curious animal will someday look up at the sky and wonder, softly, where all those lights came from. At the center of a supernova, something else often remains: a neutron star. Imagine taking the mass of our sun and compressing it into a sphere only about 20 kilometers wide. A single teaspoon of its material would weigh as much as a mountain. Neutron stars spin, sometimes hundreds of times per second, and sweep great beams of radio waves across the sky. When those beams sweep across Earth, we detect them as steady, astonishingly regular pulses, pulsars, the lighthouses of the cosmos. And if the star was truly enormous, 30 or 40 times the mass of our Sun, even a neutron star cannot hold itself together against the inward pull of gravity. In that case, its collapse continues, all the way down, into a single point whose gravity is so strong that nothing, not even light, can escape: a black hole. For a long time, black holes were mostly a theoretical idea. But in 2019, and then again in 2022, astronomers captured the first ever images of them: soft orange rings of glowing gas curved around dark, silent centers, the extreme quiet punctuation of the most massive stars. So when you look up at the night sky, it helps to remember that every star has a story, and every star is part of a far longer story. The atoms in the soil beneath your feet, the iron in your blood, the calcium in your bones, the oxygen you breathe, the gold in your wedding ring, the carbon in the pages of every book you have ever loved. All of it, every atom heavier than helium, was forged long ago, deep in the hearts of stars. You are a temporary, conscious arrangement of starlight, made of the long, patient breath of suns that finished their work before Earth itself began. And the story continues. Tonight, somewhere in the universe, new stars are being born from the clouds of ones that have died. Tonight, a middle-aged star like our own is shining calmly, perhaps with planets, perhaps with oceans, perhaps even with something very like a child, looking up at its sky and wondering. Tonight, a red giant is gently exhaling its outer layers into a beautiful nebula of color. Tonight, a white dwarf is cooling slowly into the dark. Tonight, a supernova is flaring for a brief, bright moment, seeding the galaxy with new elements. Tonight, a neutron star is pulsing softly, a quiet heartbeat in the deep sky. The life cycle of a star is, in its essence, a story of giving. A star gathers itself from the gifts of older stars. It shines generously for billions of years, and then, in its ending, it gives everything back. Its atoms return to the great nebula of space, ready to be shaped again into stars, planets, living bodies, and perhaps, someday, into the quiet breath of another person, on another world, lying in the dark and watching the sky and feeling strangely, softly. At home among the stars. As you listen tonight, as your own breath slows, as your own thoughts begin to settle, imagine that you are made of stardust because you are. Imagine that you are part of the same long, generous story because you are, and allow yourself to rest within it, held by a universe that is, at heart, far more patient and far more kind than we ever quite know. The stars keep their long, luminous watch. They have been turning through their slow, radiant lives for billions of years, and they will keep turning for billions more. You are welcome here. In the soft light of their enormous, quiet story, rest gently, rest deeply. Rest within the patient, shining heart of the universe itself. Let us pause for a moment to marvel at something even stranger: the fact that the elements of which we are made were not created quickly, or casually, or cheaply. They were created, atom by atom, in a kind of long, generous chemistry over billions of years. You contain, right now, hydrogen that has existed since the first few minutes after the Big Bang itself, nearly 14 billion years ago. You contain carbon and oxygen that were forged inside stars that lived and died long before the sun was born. You contain traces of heavier elements, like iodine and zinc and selenium, forged in titanic supernova explosions. You contain perhaps a small gold atom or two created in the collision of two neutron stars, billions of years ago, somewhere in the distant depths of a different galaxy entirely. These atoms, after their violent forging, drifted quietly through space for ages. Some of them were gathered into the cloud that would become our solar system. Some of them became part of the rocky material that formed the Earth. Some of them passed through countless generations of plants and animals before arriving, finally, in your own body. You are, in the most literal sense imaginable, a continuation of the universe, a small, conscious expression of its long, patient creativity. And when you breathe, you exchange atoms with the world again. Some of the oxygen molecules entering your lungs this very evening have been breathed before, perhaps by your ancestors, perhaps by trees in a forest you have never seen, perhaps by a blue whale crossing the Pacific, perhaps even by a dinosaur who once looked up at the same sky. The atoms circulate patiently through all of us. We are not, any of us, truly separate from the great, slow chemistry of stars. Consider too how varied the lives of stars can be. A star's fate is written in large part by a single number, its mass at birth. A small red dwarf, far less massive than our Sun, may live gently for 1 trillion years, burning its hydrogen so slowly and so efficiently that the universe itself is not yet old enough for any red dwarf to have ever reached the end of its life. A massive O-type star, by contrast, may burn so fiercely that it runs through its fuel in just a few million years. Bright, brief, and brilliant, across the sky, every kind of stellar life unfolds at once, on every possible scale of time. Some stars are born in pairs, or triples, binary systems, triple systems, occasionally even quadruple systems. They dance around one another in slow, patient orbits. Sometimes, as one star ages and expands into a red giant, it shares material with its smaller companion, drawing out long, glowing streams of gas that feed the partner's growth. Sometimes, two white dwarfs slowly spiral together and, at last, merge, producing a particular kind of spectacular supernova, the type Ia, whose brightness is so consistent that astronomers use it as a kind of cosmic yardstick to measure the vast distances of the universe. And in the aftermath of every star, new stories begin. A nebula left by a dying star becomes the cradle of new ones. A pulsar at the heart of an old supernova remnant illuminates the clouds around it. Even black holes, though silent, still punctuation marks of collapsed stars, are not as empty as they seem. Matter spiraling into them heats to extraordinary temperatures, glowing in every part of the electromagnetic spectrum. Gravitational waves ripple outward from merging black holes, crossing the universe at the speed of light, shaking spacetime itself until they reach sensitive instruments on Earth and are translated, gently, into data that scientists read like the whispered news of ancient collisions. All of this is happening, right now, in the sky above you, as you rest, as you breathe, as you drift toward sleep. A universe of stars, quietly and patiently, is turning through its great radiant cycles, and you are a part of that turning. You are, in every soft breath, participating in the long, generous work of the cosmos. Let yourself rest in this knowledge, held by starlight, softened by the long patience of suns, cradled by a universe kinder and more creative than we ever quite understand, and drift now, gently, into the deep, luminous heart of sleep, where the stars keep their quiet, loving watch until morning,